So the evolution of the XPOL-1 antenna. So a significant amount of effort has been put over the years to improve how the XPOL-1 looks and the performance of the XPOL-1 in line with technological trends and aesthetics, making it have a modern look and in line with our Poynting brand. If I can use my laser pointer there. This guy here, this was the first version of the XPOL-1. This is the second version, which is our current version that we're selling in the market. And this is the V3 or the third version of the XPOL-1 antenna that we want to introduce. So the XPOL-1 V1, this guy here, has been in existence, was in existence since before 2019. And it was developed to work for LTE bands only. So ranging from 790 all the way to 960 megahertz and 1710 megahertz to all the way to 2.7 megahertz. And it only came in one derivative, which is a 2x2 MIMO. As you can see, it didn't even have a pointing logo. Like you wouldn't even know it's a pointing antenna. It didn't have a pointing logo at the front or at the back. It just came with a product label that was stuck there at the bottom of the antenna. So with time from 2019, the new V2 was developed or was designed. It looked more slicker as you compare it with the V1. And now it incorporated a pointing logo that came in form of a dome sticker and that was stuck there in the middle. As you notice, the bracket that was used in the V1 is the same bracket that was used in the V2. And the improvements that were done in the V2 were now it could cover up to 3.8 gigahertz. So that means it will cover CBRS and 5G bands. And it not only did 2x2 MIMO, and we also had a 4x4 MIMO derivative. So that was a very big plus. But now we're going to another addition, the V3, which is better, an upgraded version of the V2. And this now we want to make available from beginning of July in a month's time. And we want to roll out this V3 in the same radome as our current V2, with the only noticeable differences you can see there being this guy here. This is the pointing orbit that will be silk screened. Silk screened means that the O here, the pointing O, is part of the front radome. We're no longer using stickers anymore, and we decided to do a silk screen on the front radome. Another noticeable difference you will see there is these small things here we are calling the ribs that are found in the brackets. They are actually in the 4 holes on the bracket, and this is just to secure our new and improved suction caps that we are introducing with the V3. So this will be available from July 2025, and we thought this will be a good way to just show you where the XPOL-1 has come from. It looked like this. This is the current V2 that we are currently using, and this is what we want to deploy. I'm sure most people have never seen this antenna before, but hey, this is where we started from, and this is where we are heading. Looks better coverage and better performance. So the other reasons why we're developing now the V3 is because we want to introduce a better version of the current XPOL-1 that our clients have come to know and trust in performance over the years. So we are building on a legacy. So it will be familiar to our clients out there, being our second best-selling fixed wireless antenna over the past decade. So it's not a completely new antenna. It's familiar to our clients. People trust its performance, and we want to build onto this legacy. Another factor is more frequency bands are now available for 5G. So the current V2 only works until 3.8 gigahertz, but now more frequencies are now available for 5G applications that go all the way until 6 gigahertz. So we need to future-proof our antennas, which is what we have done with our current, with the V3 that we want to introduce. There is also an increase in competitor antennas for fixed wireless access that are now covering these new bands that are available for cellular technologies. Our V2 is actually late to the party, and we needed to catch up, which we have done with the V3. So we've made sure now it covers all the frequencies that are available for 5G deployment. So anyways, better late than never. But yeah, we are hoping that it will be a competitor in this market, and will be able to bridge that gap that we are seeing right now. So what is the XPOL-1 5G Plus antenna? It's a cross-polarized, omnidirectional, wideband 5G antenna, and it's a successor of the current XPOL-1 5G. So the current one is the V2, so we are going to a V3. So the V3 will succeed the V2. Understanding the name, it's very important to understand the name, as we have seen people can easily relate to it. When you say an XPOL, what do you mean? So a lot of thought was put into the names that we give our antennas, and the XPOL here stands for the antenna series name. So the antenna elements inside this enclosure are cross-polarized antennas, and that's why we used the name XPOL there as our antenna series name. The one is actually the Genesis model. This was the first XPOL antenna to be designed and manufactured for pointing for fixed wireless access. This was very interesting for me. This is something I actually did not know. I had to do my research, but I actually came to find out the one there is just not a random number. It's because it was the first XPOL antenna that was developed in pointing for fixed wireless access. That's why it's a 1. And as you know, now we have 2, 6, and other 24. We have other variations, but this, the XPOL-1, was the Genesis model. So it was there in the beginning. The 5G Plus, we have that plus there. That's the extra factor. There's something extra there. What this means is the coverage frequency now has now been expanded as you compare it with the current XPOL-1. And now the performance is much more better compared to what we are having. So hence, we have the plus factor. So let's look at the specifications of this new antenna that we want to introduce. We look at the electrical specs as well as the mechanical specifications. The XPOL-1 5G Plus covers an ultra-wideband frequency from 410 megahertz all the way to 6,000 megahertz. What this does is it will ensure it's compatible with the old technologies, the current technology, and the future technologies that are being released. So we are future-proofing our antenna. And why do we need the low frequencies? The low frequencies, especially in cities, are very important because they will be able to penetrate walls and buildings very easily compared to the higher frequencies. So this is very important to have those higher frequencies for cities or dense for urban deployment, because these signals can easily penetrate walls, and the mid to high frequencies will provide you with a high bandwidth for faster data rates, especially in demanding environments. So by supporting the low, the mid, and the high frequencies, you'll be able to provide a robust coverage across urban infrastructure. We were able to achieve a peak gain of up to 7 dBi with the V3 version. We are saying up to 7 dBi because we measured the 2x2 configuration separate from the 4x4 configuration. So we achieved a peak gain of 7 dBi with the 4x4 configuration of the XPOL-1 antenna, which is actually more than double the peak gain of our current XPOL-1 V2. So what this will mean is you have increased gain. So what are the benefits of this increased gain? You'll have greater range. You'll have an improved signal to noise ratio. You'll have enhanced building penetration, and of course you'll have higher throughput. So that's a very important or a key feature for the V3. The antennas are cross-polarized, as I mentioned, and they come in a 4x4 MIMO format or a 2x2 MIMO setup. So why are we using cross-polarized antennas for this XPOL-1 5G Plus? It's because, again, this antenna is supposed to be used in urban environments. And in urban environments, we have a challenge called multipath propagation. So this occurs when signals are being reflected off buildings, off trees, vehicles, or any obstacles along its path. And when it's arriving at the receiver, it will arrive in multiple paths and different polarization. So what cross-polarized antennas will mitigate all these negative effects of the signal arriving in the different paths and different polarization, and at the same time, it will support high data rates, ensuring there is efficient and reliable communication. And why MIMO and not CISO? Why did we not go with the CISO antenna? MIMO is very important because you'll be able to transmit multiple data streams simultaneously over the same frequency, and this will double your data rates, potentially double your data rates, which will result to a high data throughput. So it comes with a 2x2 MIMO or a 4x4 MIMO configurations. On the mechanical specs, it has an overall dimension of 246 millimeters in height, 157 millimeters length, and 88 millimeters in thickness. This is including the bracket, because when the antenna is assembled and packaged in the gift box, it's included with the bracket already mounted on the antenna. So that's why we are saying including the bracket, because they are not packed as individual elements. So it's already assembled to the antenna, and those are the overall dimensions. It's actually compact and very small, which is a big plus. It has an IP65 rating against dust and water intrusion. The 6 here on the IP65 signifies that the antenna enclosure is actually completely dust-proof or dust-tight. This is comes in handy in environments that are very dusty, like construction sites or industrial areas where there is a lot of dust. So having that 6 in an antenna spec is very important, because it will show the enclosure is actually completely dust tight. The 5 here indicates that the antenna is protected against low pressure water jets from any direction. This means that it can withstand heavy rain, splashing, and even cleaning with a hose. So no water will go in there or any dust that will interfere with the performance of the antenna over time. The antenna is IK10 rated for impact, meaning that the antenna is protected against strong mechanical shocks. For example, accidental knocks, it can be hail or any vandalism attempts, and it can be pole, wall, or window mounted just as our current XPOL-1 V2. So this is just a graphical representation of the frequency bands that the XPOL-1 works for. It works from 410 megahertz all the way to 6 gigahertz. So it's future-proof. So it's covering the old bands, the old technologies, the current technologies and the emerging technologies. And it also covers Wi-Fi bands 2.4 to 2.5 and 5 to 6 gigahertz. So this antenna can actually work for Wi-Fi reception. So next, let's look at the sales verticals. So where do you use this XPOL-1-5G PLUS? So XPOL-1-5G PLUS is primarily for fixed wireless access deployments, and is ideal for delivering reliable broadband connectivity in urban and commercial and industrial verticals. This can be your homes and small offices in both urban and suburban environments, and small to medium businesses across the commercial and industrial sectors. So this can be your supermarkets, it can be your warehouse, it can be the banks, it can be your restaurants, guest houses, schools, or even temporary offices on construction sites. So these are a few examples of small businesses and commercial setups where the XPOL-1 can be used to deliver reliable broadband connectivity. All you do is find a good spot to mount your antenna outdoors and you're good to go. So it's basically used for small businesses and homes in urban settings. All right, let's now look at the benefits of a good and stable connection. So your XPOL-1 5G antenna, we know, will provide you with a good and stable connection. Why do you need a good and stable connection at home or in the office? When you have a good and stable connection, you'll be able to work remotely and you'll be efficient at it. You'll have uninterrupted communication. You'll have access to your emails. You'll be able to do your meetings via video calls or even messaging apps. You'll have access to your entertainment platforms. You can do media streaming, online gaming, social media, just to mention a few. Business continues as usual because now you have stable connectivity without interruption. Your smart home devices will be able to be connected to this stable connectivity that you have, and everything will be seamless. And guys who are doing e-learning will be able to access online education and learning platforms without any interruptions at the comforts of their homes or offices. In the commercial and industrial sectors, the benefits of having a good and a stable connection. You'll be able to have operational efficiency. You'll be able to manage your supply chains, inventory, and logistics, just to mention a few. You'll be able to collaborate well between your staff and departments because there's that connectivity now. Real-time data collection and analytics will be possible. You'll improve your customer service and support through chatbots, AI-driven customer service and support software. You'll have increased security and surveillance because now your security devices are now connected to this stable and good connectivity that you have. You'll enhance your employee productivity and satisfaction because they'll have a better work experience. They have connection to the internet. There'll be higher productivity and job satisfaction, and the ultimate failover solution for uninterrupted connectivity. So you can use your XPOL-1-5G PLUS as a secondary backup. So it will be your backup option, especially for businesses that have the primary connection of maybe fiber or even Starlink. If fiber fails or your primary connection fails, then you can seamlessly move over to your XPOL-1-5G PLUS connection without any interruptions. So it can also be used as a backup to your primary connections that you may have. So product configuration, the XPOL-1-5G PLUS will be available in the following configuration. We have the XPOL-1 V321. This will have 2 cellular ports. So it has 2 antenna elements inside the radome. And the V341 will have 4 antenna elements inside the radome. So these are the only 2 variants that we'll have for the XPOL-1-5G PLUS, which is the same as we have for the current V2. So this is how the antenna elements are actually mounted inside the radome. So on your left, this is the 2x2. We have 2 antenna elements there, slanted 45, positive 45 and negative 45 degrees there in the middle. And we have the 4x4 version that has the slanted ones, positive and negative 45 there. And then we have these guys here at the back, which is horizontal and vertical antennas. So for the XPOL-1-5G PLUS, we actually used 2 high-performance antennas, which are these in blue, the ones in blue, and 2 versatile or low-performing antennas, just because of space constraints and for us to achieve the performance we were looking for, up to 6 gigahertz. So these are the high-performing antennas, and the lower-performing antennas are in orange there, as you can see at the back. We used a PCB support frame. This is something that was not there in the current V2, just to hold these antenna elements firmly in place, preventing any movement or flexing of the PCBs during installation or transportation or exposure to vibration. And having this support frame will keep the antenna elements in the exact alignment during assembly. They'll be assembled the same all the time. So this will help us to achieve repeatability in the production, during production or mass production of the antenna. So both antennas span from 410 all the way to 6 gigahertz. For the 2x2, the peak gain we were able to achieve there was 6 dBi, which is almost double the current peak gain. And the peak gain we were able to achieve with the 4x4 version is 7 dBi, which is more than double our current V2. Next, let's look at our measured results. I will start with the 2x2 derivative, we will look at the VSWR, the peak gain, as well as the isolation. Please note that the VSWR and the gain and the isolation measurements you're seeing there are for single antenna elements. If you look at the VSWR, just as a reminder, it stands for voltage standing wave ratio, and is a measure of how efficiently an antenna is transmitting power from a source without reflecting it back. A low VSWR means that the antenna is transmitting most of its power without reflecting it back, but a high VSWR will mean that most of this power is being reflected back instead of being transmitted outwards. So for the 2x2 or the 21 variant, we have a VSWR of less than 2 to 1 over 90% of the band, which is acceptable. For the gain again is a measure of how effectively an antenna sends or received energy in a given direction compared to a reference. So the XPOL-1 V321 has a peak gain of 6 dBi at the 3300 to 4200 megahertz band, which is almost double the peak gain of the current V2. And what this means is now you'll have greater range and higher throughputs compared to the current V2. Please do not be alarmed by the negative gain you see there on the lower frequency bands, because the antenna, this is acceptable and the antenna will still work beautifully, because at 400 megahertz, the signals will still propagate extremely well because they have a longer wavelength. So they'll be able to penetrate buildings and foliage or obstacles, and they experience very low free space path loss. So it should not be an alarm or something like that if you see the negative gain, especially on the lower bands. The antenna will still work at those bands. Isolation, it actually refers to the degree in which these antenna elements inside the radome are decoupled from each other. So that means they should be able to independently operate without interfering with each other or any signal leakage leaking from one to the other. So, and good isolation is usually less than 10 dB, as you can see there, and that is what we actually achieved from 410 to 6 gigahertz, which is very impressive. So looking at the 4x4 derivative of the XPOL-1 V3, we measured the VSWR again, the peak gain, and the isolation. We achieved a VSWR of less than 2.5 to 1 over 90% of the band, which is acceptable, and a peak gain of now 7 dBi in the higher bands. That's from 3.3 all the way to 4.2 gigahertz. This is more than double our current peak gain for the V2. Of course, now we'll have greater range and higher throughput just because now the gain has doubled. That's a big plus. And on the isolation, you see we achieved an isolation of less than 10 dB. That means now all the elements inside the same radome, we have 4 elements, will be able to independently operate without interfering with each other. So moving on to the radiation patterns, I will also start with the 2x2, which is the 21 variant. We considered a single main element for the elevation patterns, and for the azimuth, we considered all or a combined patterns for all the elements, the 2 elements in the 21. As you can see there, I've not included all the bands because we had a lot of measurements. I've just picked a few from the measurements we got from our RF department, just to illustrate the measurements we got or the results we got. So the elevation, if we start with the elevation, there is a side view. So this shows you how the antenna is radiating in the vertical plane. So instead of, you're looking at the antenna from the side instead of looking at it from the top. So as the lower frequencies there, there's a lower gain, and hence there's a wider elevation beam width, and the higher frequencies there, as you go towards the higher frequencies, the beam width narrows now with more energy being focused at the horizon, which is the 0 point. And for the azimuth, as I mentioned, we considered a combined patterns for both antenna elements, and it shows you how this antenna radiates from a bird's eye view, so from the top view. And these patterns just for illustrating how the elements will be radiating in a MIMO operation. And you can see there is consistent signal reception in all directions, as there's constant omni patterns from 410 all the way to 6 gigahertz. So looking at the 4x4 MIMO, and next is the same thing. We considered a single element for the elevation patterns and combined 4 elements for the azimuth, just to illustrate the MIMO, how MIMO operation will be. As I mentioned earlier, here lower frequencies have lower gain, hence a wider beam width compared to the higher frequencies where the gain now is more and then the beam width narrows down, so you'll have better range there, but here you'll have a wider vertical beam width. For the azimuth there, you'll see have consistent or constant omni patterns all the way from 410 to 6 gigahertz, which is will give you consistent signal reception in all directions. So let's look at the external look and the dimensions of our XPOL-1-5G PLUS. So I included the dimension plus the bracket there. So it's from the top to the bottom. Every dimensions that is in this slide included the bracket, because this is how the antenna will come from the gift box. It has a height of 246 millimeters, a length of 157 millimeters, and a thickness or a width of 88 millimeters. It's a small and compact, which will make it less visually intrusive. This is important in residential or commercial or commercial buildings, and it appeals to clients or customers who want connectivity without, for the lack of a better word, ugly hardware on display. So it's compact, it will just blend in with the environment it is mounted on, and the small size makes it ideal for areas with strict building aesthetics or regulations, and comes in very handy in urban environments with limited space. And just because it's small, you can move around with it, and this is useful in temporary setups like events or mobile offices. So you just move around with it, put it up. Once you're done, you just pack it and move around and take it with again. So it's very small and compact, and it will blend with the environment where it will be mounted on. So looking at the mounting options, the V3, which is this new version, will have the same mounting options as our current V2. It can be pole mounted, and pole mounting will happen using the pipe clamps. We actually include this pipe clamp with the XPOL-1 antenna that goes from the bracket and goes around the pole. It can be wall mounted using wall knocking screws. We provide also wall knocking screws. There are actually 4 that go through the bracket there at the bottom, as you can see. And it can be window mounted. So window mounting also will have the sucker or use suction cups, and these suction cups are the new and improved suction cups I was talking about that have screws just for easy assembly or easy fastening at the back of the bracket. So they go through the bracket also. As you can see, this is a versatile bracket. You can use it for the pole, wall, and window mount options. So what are the key selling points of this new antenna, the XPOL-1-5G PLUS, which is the V3? It now has an ultra-wideband coverage from 410 to all the way to 6 gigahertz. We have future-proofed this antenna now. You don't need to use multiple antennas for you to get other bands or coverage in other bands. You have optimized performance. We have achieved a high peak gain of 7 dpi, which is more than double the peak gain of our current XPOL-1 antenna. What this means is you'll have superior signal strength and extended coverage. it comprises of 2x2 or 4x4 MIMO cross-polarized 5G antennas that are also compatible with LTE. And what this will help with is you'll get higher data throughputs and stable connectivity. More key selling points for the new antenna are the cellular antennas. They've been designed such that they can also work for Wi-Fi frequency bands. So you can also use this antenna for Wi-Fi reception. We have updated the radome design just to align with our Poynting branding. There are versatile mounting options for ease of installation. We have the pole mounting option, we have the wall mounting option, and we have the window mounting option. All these options use our versatile bracket. And the antenna will be available in two derivatives. We have the 2x2, which is the V321, and we have the 4x4, which is the V341. So thank you very much. That brings us to the end of the XPOL-1 5G Plus product launch.